So we now need to start talking about how to actually find these absolute maximums and absolute minimums. And one of the important ideas we're going to need to use is the idea of a critical value. Before I get into that, absolute extrema could occur at two different places. They could occur at the endpoints of my function, like I saw in some of the things on the first page. I had an absolute max occurring here. Or, well, at specific x values within our region. And the specific, like over here. And those specific x values within our region we're going to call critical values. So I first want to say absolute extrema can occur at the end, whoops, not 8, at the endpoints of our region, or at specific x values within our region. And we call those specific x values critical values. Take a moment and copy down that definition, or not really definition, just sort of explanation. Here's our definition. X equals C is a critical value, a place where I could have an absolute max or an absolute min. It is a critical value of f of x if either f prime of c equals 0 or f prime of c is undefined. X equals c is a critical value of f of x if either the derivative there is 0, for example, maybe something like this. Looks like I've got a minimum over here, and my derivative there is 0. Or if f prime of c is undefined. If my function's not differentiable there, maybe something like this, at the sharp turn on an absolute value function. Critical values occur if the derivative of my function either equals 0 or is undefined. Take a moment, copy that down, and then we'll start finding some of these. First example, we want to find the critical values of f of x equals x cubed plus 6x squared minus 15x. I want to find the critical values of that function. Well, the first thing you need to do is find your derivative. So take a moment, get your derivative. My derivative should be f prime of x equals 3x squared plus 12x minus 15. And then I need to figure out what makes my derivative equal 0 or what makes my derivative undefined. Well, my derivative, it's a polynomial. Won't ever be undefined, but it will equal 0 in some place. So I'm going to say 3x squared plus 12x minus 15 equals 0. I think I can factor out a 3 here. 3 times x squared plus 4x minus 5 equals 0. I can continue factoring and say 3 times x plus 5, x minus 1 equals 0, which will give me x equals negative 5, or x equals positive 1. Those are my two critical values. Those are places where I could possibly, I'm not really sure, but I could possibly have an absolute maximum or an absolute minimum. Let me show you a few harder examples. Next one, we're going to find the critical values of f of x equals x to the 3/4 minus 2x to the 1/4. And you go take a moment and find your derivative. Derivative should be f prime of x equals, okay, this is 3/4 x to the subtract 1 from the power, negative 1/4, minus 2 times 1/4 x to the subtract 1 from the power, 1/4 minus 4/4 is negative 3/4. And I'll clean it up a little bit and get 3/4 times x to the negative 1/4 minus, or you know what, let me leave it as 2/4. We'll see why in a moment. Minus 2/4 x to the negative 3/4. I need to figure out when this is 0 or when this is undefined, and it's not in the best form for me to be able to do that. I need to go do a little bit of factoring. I'm going to take out my x to the lowest power. Well, I've got an x to the negative 1/4. I've got an x to the negative 3/4. I'm going to take out an x to the negative 3/4. I'll be left with 3/4 x raised to the, okay, so negative 3/4 plus what would give me negative 1/4? I think that's 2/4. Clean that up in a moment. Minus, well, just 2/4 over there. I'm going to keep going, and I'm going to get f prime of x equals, let's see, I'll leave this stuff on top, so 3/4 x to the 1/2 minus 2/4 all over x to the 3/4. I have to get rid of my fractions inside fractions, so I'll multiply the top and bottom by 4 to get my derivative in a better form that I can now work with is 3x to the 1/2 minus 2 over 4x to the 3/4. But that's just half the battle. I now need to figure out when the derivative is 0 and when the derivative is undefined. I need to figure out when f prime of x equals 0 and when f prime of x is undefined. Well, for a fraction to equal 0, what part of the fraction has to equal 0? The top, the bottom, or both? For a fraction to equal 0, the top has to equal 0. So we're going to say 3x to the 1/2 minus 2 equals 0. What must be true if a fraction is undefined? The denominator is going to equal 0. So really, all I have to do is set both parts of my fraction equal to 0. Go find your critical value from this piece. I'm going to get 3x to the 1/2 equals 2. I'm going to get x to the 1/2 equals 2/3. I'm going to get rid of my 1/2 power by squaring both sides, which gives me x to the 2/3 squared, so 4/9. Go figure out what you get when f prime of x is undefined. Divide both sides by 4, we get x to the 3/4 equals 0. Raise both sides to the 4/3. Well, it doesn't matter, 0 to the 4/3 is still 0. I have two critical values. My two critical values are x equals 4/9 and 0. All we need to do to find critical values is find the derivative, then set the numerator of our derivative equal to 0, and set the denominator equal to 0. Let me show you a few more. F of x equals 4x over x squared plus 1. Take a moment and find your derivative, making use of quotient rule. This is not when I would use product rule and chain rule. Quotient rule is going to be easier on this one. Find your derivative. low, x squared plus 1, d high is times 4, minus high, 4x, d low is 2x. Draw the line, square below, this is over x squared plus 1 squared. That gives me 4x squared plus 4 minus 8x squared over x squared plus 1 squared. F prime of x is going to equal, looks like 4 minus 4x squared over x squared plus 1 squared. That's our derivative. Now we need to find our critical values. So I'm going to set f prime of x equal to 0. And I'm going to figure out when f prime of x is undefined, which really means set the numerator equal to 0 and set the denominator equal to 0. And I can ignore the square because, well, square root of 0 is still 0. If this thing is 0, my denominator will be 0. When the numerator equals 0, what do you get? Let's see. So 4 equals 4x squared. Divide by 4, x squared equals 1. X equals, don't just tell me square root of 1, but it needs to be plus or minus the square root of 1. So we're going to get plus or minus 1. Where does the denominator equal 0? This gets a little unpleasant. X squared equals negative 1, so x equals plus or minus square root of negative 1 plus or minus I. But I think I've mentioned a couple times in this class, actually maybe I haven't, maybe this is the first time this is going to matter. We are only going to care about real numbers in here because I can't really have plus or minus I when I'm going to graph things. So no, my denominator is never going to equal 0. My critical values only come from the numerator, and they're x equals plus or minus 1. 2 more examples for this video. Got to do some trig. Oh, that'll be fun. F of x equals 2 secant x plus tangent x. And I want to deal with this on the interval from 0 to 2 pi. Go find your derivative. F prime of x is going to equal 2 secant x tangent x plus secant squared x. I'm going to try to clean this up a little bit because I've got to be able to set a numerator and denominator equal to 0. I'm going to factor out my GCF, which looks like a secant x. We're going to get 2 tan x plus secant x. And I'm going to have a much easier time if I can rewrite this in terms of sines and cosines, because then I'll actually get some numerators and denominators. So I'm going to say f prime of x equals 1 over the cosine of x times 2 sine x over the cosine of x plus 1 over the cosine of x. So that's kind of nice. I already have a common denominator happening there. So my derivative is going to become 1 over the cosine of x times 2 sine x plus 1 over cosine x. And I can turn that into 2 sine x plus 1 over cosine times cosine, cosine squared x. And that's my derivative. We now have to set the numerator and denominator equal to 0. So 2 sine x plus 1 equals 0. Cosine squared x equals 0. Where does that numerator equal 0? Well, subtract 1. You're going to get 2 sine x equals negative 1. Divide by 2. Sine x equals negative a half. Where's the sine negative a half? I think that happens at 7 pi over 6. And my favorite angle, 11 pi over 6. Where's the denominator going to equal 0? Where's the denominator? That cosine squared x going to equal 0. Do the plus or minus square root of both sides. We really just want to figure out where the cosine of x equals 0. Cosine is 0 at pi over 2 and 3 pi over 2. So in this one, I have 4 critical values. 2 came from the numerator, 2 came from the denominator. Last one for this video. Let's look at the function f of x equals negative the absolute value of x minus 4. F of x equals negative the absolute value of x minus 4. I need to figure out where the derivative is 0 or undefined, but this is going to be an absolute pain because I don't want to deal with those absolute value bars. I know I can rewrite this as like a piecewise function and stuff, but let me show you a little shortcut. I know what the graph of this looks like. It's an absolute value v, shifted 4 to the right, and what does that negative out front do to it? Flips it over the x-axis. So I have a graph that looks something like this. And it's totally fine to cheat for something like this. The derivative never equals 0, but I think the derivative is undefined right over there where we're not differentiable, where we have a sharp turn. Therefore, I have a critical value at x equals 4. Why? Because f prime of 4 is undefined. If you're dealing with an absolute value function, I think we can just think graphically and figure out where our sharp turn is, and that'll be good enough. Anything else, though, we do need to go through our derivative work.